Hello students, we have already given the worksheet to you. We have provided you two worksheets, one worksheet based on unit and dimensions and other based on what? Measurement. So hope you have solved those exercises already, and today we are solving those two DPPs given to you already. Okay? Yes. So as we have provided the solution sheet also for this DPPs already to you, still I will solve few problems which are little critical types, or you may confuse on those problems. Those problems only I will discuss here. Okay? Yes. If I skip any problem which you want to learn, you can ask that in the comment section. I will solve in the next video those problems for you. Okay? Yes. So let's start. First I am talking about the first sheet that we have given to you based on units and what? Dimensions, right? Yes. Okay. So the question number 1 in the first sheet says that LCR represent inductance, capacitance and resistance, then which of the following does not represent dimension of frequency? They are asking dimension of what? Frequency. And it's a very basic thing, you know, frequency is nothing but what? 1 by what? Time. Frequency nu is what? 1 by time, opposite of the time, correct? So in lecture I have discussed the dimensions of the time. Remember, it's very important, it's called time constant, and 3 formulas I gave for time constant. The time constant I have spoken to you. I am talking about question number 1. Time constant, these things I have spoken. Time constant are what? We have L by R, then we have LC, root LC, then we have R into C. These were the 3 time constants, right? Because their dimensions are equal to what? Time. Now question is here, who is not the dimension of frequency? Frequency is just opposite of the time, right? So if you write frequency formula, they are just opposite of this. Means frequency you can write like R by L, you can write 1 by root LC, you can write, or we can write 1 by RC. These are the frequency. These will give dimension of frequency. So see in our option, 1 by RC is given, yes, this is a dimension of frequency. Okay, R by L given in second option, that also correct, this is a dimension of frequency. 1 by root LC given in third options. So fourth option they have given wrong. They said frequency is equal to C by L. No, this is not frequency, correct? So basic formulas are what? Time constant formula. I have explained you many things, like they can change small things, like they can remove root here, just write LC, then this become what? Time square, or they write 1 by root LC, like just this much, then become what? Frequency square, so it become time power minus 2, right? So these things you have to understand. Okay. Question number 2 already have solved in the classroom, right? I think all values I wrote correctly only, that a number of particles crossing a unit area perpendicular to x axis in unit time is given by this formula, and we have to find the dimension of what? Diffusion constant. So I have already solved this problem. You can see in I think lecture number 4, this problem I did during the theory lecture. Okay, please sit there. Correct answer is what? Delta. Option 4 is delta is the correct answer for question number 2. Okay, yes. Okay, we are talking about third question now. So already I told you, like you cannot find all dimensions right now because you don't know the complete formulas, because dimension they can ask from any chapter's formula we have to use, and if you are in 11th or just now in 12th, then you have not learned everything, so you don't know all formulas, so you should not worry about them. If you are already 12th passed, then you should worry little, you should know the formulas to answer any questions based on dimensions. Okay, if you are in 11th and 12th class right now, then you should not worry because you don't know all the formulas. Like question number 3 and 4 where formula from different chapter coming, thermodynamics, magnetic, and this from this chapter the formulas are coming, we should not worry about them. Okay. Okay, let's solve third problem. Okay, so it says that some formula is given, x is equal to 3 times y and g square, and they have mentioned what they are. They said that y is the capacity or capacitance. Okay. Yes, and G is the magnetic field. Find the dimension of what? No, sorry, I wrote I think wrong. X is the capacity and G is the magnetic field. We have to find dimension of what? Y. This is the question. So If you are in 11th and just started with the 12th, then you cannot answer because you don't know the formulas of capacitance and magnetic field, how they are related with other quantities. If you are already 12th pass, then you should know, you should be able to answer this question. Okay, let's see how to answer. So you have to find dimension of y. So rearrange this formula, you will see y is nothing but simply x by 3 g square. 3 doesn't matter in dimension because constant has what? 0 dimension. Okay, we have to find dimension of x and what? G means capacitance and what? Magnetic field. Let's find dimension of capacitance. How you will find? So how you will find? Let's sit here. Write any formula where capacitance comes. Popular formula is what? Energy formula. Energy is equal to half CV square or half Q square by C or half Q into V. Many formulas are there. You can use any one. Okay. Yes. So if you use this formula, then again you need the dimension of potential. We don't know. This is easy. Charge. Okay. So I use this formula. E is equal to half Q square by C. I have to find C, which is what? Q square by 2E. 2 has no dimension again. So energy dimension I know, and charge is very simple. You know, charge is nothing but, okay, I write like current formula is what? Rate of flow of charge, Q by T. So your Q becomes what? I into T. Current dimension write as what? Ampere, A symbol or I symbol, depends on what question. Like here they wrote what? A symbol for current. Okay. So let's answer now. What is the dimension of capacitance? C is equal to Q square means what? I into T. So become ampere square times square divided by energy m power 1 L power 2 T power minus 2. So this become A power 2 m power minus 1, L goes up, L power 2, and this goes up, sorry, L power I should write minus 2 and T power what? Plus 4. This is one thing we needed. Okay. Then we need one more dimension. We need dimension of what? Magnetic field. Let's find. So we write any formula where magnetic field comes like E by V, then we have to calculate magnetic electric field dimension. So easier one is what? The magnetic force formula. Magnetic force on a charge moving through magnetic field. So that formula is called like charge into velocity into what? Magnetic field. This is the easier one. So here we have to find B. Let's find it. F by Q into V. So once more I am reminding you, if you are in 11th and 12th class, then you don't know all formulas, should not worry about them. They are very simple once you learn those chapters. Okay, force we know m power 1, L power 1, T power minus 2. Charge we have learned is current into time. So ampere power 1, T power 1. Velocity is L power 1, T power minus 1. So how much this comes? M power 1, A goes up, A power minus 1. Okay, and this T get cancel here, this L get cancel here, we getting T power minus 2. This is the dimension of magnetic field. Now both things we have found, capacitance and magnetic field, let's put them in this formula Y. So Y is equal to X. X means what? Your capacitance, which is what here, let's write here, A power 2, M power minus 1, L power minus 2 and T power 4 divided by Z square. Z was the magnetic field and square of this number. So square it, m power 2, A power minus 2 and T power minus 4. Let's solve this. A goes up becomes A power 4, m goes up becomes m power minus 3, okay, L power minus 2 and T power 8. This is the answer we are getting, dimension of Y quantity. So if you see our options, then yes, we see that option number 4, delta option is what? Matching here. T power 8, yes, A power 4, correct, M power minus 3 and L power minus 2. That's our answer, fourth option, right? Yes. So questions are easy, only just we need to understand and remember all the formulas. Right now, if you are, as I said, you are beginning, then you don't know all formulas, should not worry about these type of questions, okay? Yes. Only dimensions of everything you cannot calculate right now. Other questions you should be able to answer based on unit or mainly on what? Errors. Okay. Okay, let's move to the next question, fourth question, which says that some formula is given. Some similar type of question I have discussed with you. So this is given alpha by beta something and exponential function is given alpha into z upon k into what? Theta. This is given, okay? Yes. So here they have explained the meaning of all quantities that coming here. So what they said, P is the pressure, okay, they have mentioned that P is the pressure, then Z is the distance, I am writing it shortcut, distance, and K is Boltzmann constant, right? Yeah. And theta is the temperature. So here only one thing you don't know is what? Boltzmann constant. It comes in thermodynamics, okay? You should not worry, okay? Yes. We have to find dimension of alpha and beta. So first you have to understand that this is a mathematical function, so I have to use that rule that all mathematical functions has what? Zero dimension, right? Okay. So let's pick this whole term. You say alpha z by k theta should be equal to 0 dimensions or equal to what? 1. We have to find dimension of alpha. So alpha will be k into theta by what? Z. Now z is distance, you know, theta is the temperature. You can write theta itself generally we write like how they wrote here. Okay, you can write in terms of what? Theta itself. Okay. Now we have to find dimension mainly what? K thing, which you don't know. So Boltzmann constant comes in many formula, and simplest formula is what? Our thermal kinetic energy. You can write energy is equal to what? Half k into theta. That's all. Okay. So it's very simple. K is nothing but this has no dimension. Energy by what? Theta. Energy we know m power 1 L power 2 T power minus 2 divided by theta become theta power minus 1. This is the dimension of K. Let's put it here. So alpha becomes how much? K. M power 1 L power 2 T power minus 2 theta power minus 1 into theta power 1 by what? Z means distance L power 1. This theta get cancelled here. So alpha comes m power 1 L power 1 T power minus 2. This is the alpha. Even sometimes they ask that what is that quantity? What is alpha? Then we should see from dimension that it could be what? Force. Not always, because two things can be having same dimension. So but if they given only one option like force, then this is what? Force. Okay, we know this thing. Now we have to find dimension of what? Beta. So you can use these relations, okay, because this whole thing has the value of what? 1. So this should be equal to that. So where should I write? Let me write it here. So P is equal to what? Alpha by beta. I have to find what? Beta, which is what? Alpha by P. Here you should understand directly, save your time, because alpha we found what? Force. Force by pressure is what? Your area, correct? So you should get the dimension of area. Let's check it. M power 1 L power 1 T power minus 2. Pressure means what? M power 1 L power minus 1 T power minus 1. This is the pressure dimension. So answer comes what? L power 2. Here itself should understand that alpha we got force, we dividing by pressure, we should get what? Area answer, right? So L square should be the answer. Yes. So I am saying this like even the fifth question, this coming from our waves chapter, the frequency of a wave on a string. We don't know all these things, still you should understand that how to calculate them, okay? Now the problem number 4 we are talking. So again this is a formula I said from waves. If you know, it's okay, otherwise you don't need to worry. So let's see. Some formula is given which that the frequency of a wave on a string is given P upon 2L root, or they give power half, is okay. Yes. F by what? M and power half. This is a formula given, very popular formula. Yes. So P is the number of the segments of the string, L is the length of the string, find the dimension formula of M only. Suppose you know this formula in that chapter, then directly understand that this formula, what is this? This is called linear density. This is called tension by linear density, okay. Linear density means mass by L, and in formula if you know this mu is nothing but what? Or M symbol they wrote here. So M is what? Mass by length, mass is M power 1 L power minus 2. That's your directly answer, this much only, okay. Yes. Because once you learn that chapter, you will see this formula, which is a very important formula of that chapter, correct na? So directly you can give answer because they are asking dimension of M. So M is called what? Linear density of that wire. So mass by length, that's the answer. This is the answer itself. Suppose you want to calculate, then how you will calculate? Okay. Let's see. We have to find dimension of M. So square on both sides, we get nu square is equal to P square upon 4L square F by M. We have to find M. So rearrange this P square into F by nu square into 4 times of L square, okay. So now see, 4 is a number and P also a number. P is called here like mode of vibrations, or it's called number of the loops, right? Yes. So it has what? No dimension. These things we learn in that chapter only. Right now I cannot tell you the whole formula of the complete physics right now. Yes. So it comes chapter by chapter. Okay. Force M power 1 L power 1 T power minus 2. Frequency means T power minus 2. L means what? L square. So this get cancelled and we get simple answer as what? M power 1 L power minus 1. That's your answer. So option number what? Charlie. Third option is the correct answer. Okay. Yes. Let's move to question number 6. I will not solve because already I discussed in theory that what is the relation between dyne and Newton. Correct. So here in your sheet, the I think key was given wrong. The correct answer is, we already discussed that 1 Newton is equal to what? 10 power 5 dyne. We have learned for energy also that 1 joule is equal to 10 power 7 ox. So correct answer is this one, which is option what? Third option. Correct. Yes. And key is given in your sheet wrong. Please be careful about this. Okay. Correct answer is this one. 1 Newton is equal to 10 power 5 dyne. Okay. Here they are asking, I think opposite they are asking, right now. Okay. Sorry, here they are asking opposite. It means what is the answer? They are asking what is 1 dyne is equal to what? So opposite, 1 dyne will be equal to what? Just send it down, that number, 10 power minus 5 Newton. This they are asking. Okay. They are asking opposite, not like this way. They are not asking that what is 1 Newton is equal to what. They are asking what is 1 dyne. Now correct answer should be what? Your alpha then, right now. 1 dyne is equal to 10 power minus 5 9. So not third. What is correct answer here? First option is the correct. Okay. They are asking 1 dyne is equal to how many newtons? Opposite of this. Okay. Now question number 7, which are very important, like choosing something as fundamental. I told you the most important pattern which we have is here. Okay. Question number 7, I have to solve this. Okay. So question number 7 says that the speed of the light, gravitational constant and Planck constants are taken as fundamental units in a system. Then dimension of the time in this new system is what? Again here like a few things are coming, like speed of light, dimension, you know, velocity general, gravitational constant also you can find because it's a general formula. If you don't know Planck constant, right, then Planck constant first we learn in our modern physics 12th class. Okay. We talk about Bohr model, then we say angular momentum mvr is equal to nh upon 2 pi. Okay. So if you don't know, it's okay, no problem. Yes. So these are chosen fundamental. What is dimension? Dimension of time they are asking. So I told you how to solve this problem. You have to using dimension analysis, you have to solve this problem. So I am writing here time they are asking. This is time, depends upon few things are given. Speed of light given c plus a power x, gravitational constant given g, power y, and one more thing what? Angular momentum, let's call it what? L, power what? G. So time depends on these three things and we have to find the formula of time in terms of what? These three things. Okay. Yes. So let's calculate one by one. First step, put the dimension of every one. C dimension, you know, these two dimensions first you have to calculate. Okay. Yes. So let's calculate the dimension of these two things. Angular momentum is what we know is simple, mvr. So let's put m power 1, l power 1, t power minus 1 and l power 1. So angular momentum becomes m power 1, l power 2, t power minus 1. This is the angular momentum dimension. Okay. Yes. Okay. Then if you have to calculate g, g comes in what? Gravitational force formula. So force is equal to g m1 m2 upon r square. From here we see that g is nothing but f into r square upon m1 and m2. Force is m power 1, l power 1, t power minus 2 and r square means l power 2 m square because m into m. Okay. So dimension of g coming how much? M power minus 1, l power 2, no, l power 3 and t power minus 2. This is the dimension of what? G. Okay, let's put it here now. Time dimension is here, constant k. Speed of the light, we know velocity L power 1, t power minus 1, power x. G, this is G here. M power minus 1, L power 3, t power minus 1, power what? Y. And one more thing is what? G. Angular momentum, which is what? M power 1, L power 2, t power minus 1 and what? Pi power g. Okay. So you have put the dimension of all three quantities, speed of the light, gravitational constant and angular momentum. Now next step, you know that you have to compare dimension on both sides. So I am comparing on both sides and see, let's see what answer comes. You compare dimension of mass, then what you will get? Mass. There is no mass on this side, so it's 0. Either side mass, no mass here, mass is here minus 1 into y, here minus 1 into what? Z. So it's become minus y plus z is equal to what? 0. So from here we can see one small thing that y and z are what? Equal given. One thing. Okay. Yes. Okay, let's compare dimension of time. What do we see? Time is given their power 1. So 1 is equal to time here minus x minus 2y and minus z. So minus x minus 2y minus z. Let's call equation 1. Compare dimension of what? Length. Length is not given here. Length is given here L1 into x, 3 into y and 2 into y. So it's become 0 given that side. Here given what? X and plus 3y and plus 2z. Okay. Yes, this is the equation number 2. Now you have to solve these two equations to calculate what? Our x and what? Y and g. All three things we have to calculate. Okay. So first what we can do, we can reduce, because there are 3 variables here, all 3 are unknown. Let's reduce them into what? 2 variable. You can replace any one thing, either y is equal to z, z is equal to y, one thing. Let's replace it here. I am replacing y is equal to what? Z, suppose. Okay. So I am putting y here, what? Z. So what I get? This is become 2z, 1z, so it becomes minus x minus 3z is equal to what? 1. Again y putting here z here in this case, so it's become what? 3z plus 2z, 5z. So x plus 5z is equal to what? 0. Let's solve them. So you add them directly, this get cancelled, you get 2z is equal to 1, z is equal to 1 by 2, and this should be also equal to what? Y, because here is show y and z are what? Equal, right? Okay, 2 terms already we have found. Now we have to find x. You can use any formula. Let's use this formula or use this one, and it doesn't matter. Okay, let me write this equation here on top. Okay, G. So I have to find x. This is looking simple to me. Okay, second equation. Okay, x should be equal to what? Minus 3y minus 2z, right? Okay, G. So how much given y? Yes, y and z both are what? Just half only. So minus 3 by 2 minus 2 by 2. So this become minus 3 by 2 and this become minus 1. This become minus 5 by 2. So x is coming minus 5 by 2. X, y, z, all 3 things we have found. Now put this value again in the original formula to calculate how time depends upon these 3 things, right? Okay, let's use this formula. So time should be equal to some constant k. Okay, k. Speed power x, c power minus 5 by 2, done. G power y means half and L power also half. Let's see which option is matching for them. So question number 7 we are doing. Minus 5 by 2 is the c power, yes, h power half L. So first option is matching here. Correct answer is what? Alpha. This is the correct option for this question. Okay. Yes, this is a very important pattern in which they choose something as fundamental, then we have to find formula what? Something, right? Yes, an important question. So there is a continuous question like this. Question number what? 8 also, same question exactly. Question number 8 we are talking. Again they are saying that I choose gravitational constant, Planck constant, speed of light, then what is the formula of the radius of gyration, right? Yes, same 3 things are given to us. Just here this is given what? Radius of gyration. Radius of gyration come in rotation chapter of 11th class. If you heard about that, it's okay. Radius of gyration, simply radius only. So dimension will be what? L. That's all. Should not confuse. So similar thing, because all these 3 things are given exactly same only. Just here what they have changed. So I am not solving this problem because it's exactly same problem. These things are given exactly same, speed of the light, gravitational constant and length. Here is just given radius. Radius means put L power 1 here. You compare on both side and you get this similar way you have to get the answer. Exactly same similar problem. So I am not doing. I am telling the answer of this question, which is what? Alpha. Question number 8 also has answer as what? Alpha. Okay. Yes. Same problem. These 3 things are given exactly same. I have calculated dimension here if you don't know. Okay. Yes. Problem number 9 says that the magnitude of any physical quantity depends upon few things. So they have given option that depends on the method of measurement. No. Does not depends on method of measurement. Yes, does not depends on method of measurement. Suppose you have length, you want to measure length of this board. You use a scale or you use a vernier caliper, whatever you use any tape, your length will be length only and you will get same answer, right? Yes. So what is correct answer? That magnitude does not depends on what? Like method of the measurement. Okay. Yes. Then they are asking what is unit of Stephen's constant. So this is also simple question, but it comes in what? Thermodynamics, when we learn Stephen's formula. Okay. So you don't know that, you don't need to worry. Stephen's formula comes in this, that the energy radiated by a body is like sigma A T power 4 and time. This is a formula. The energy radiated by a body, heated body, is depend like this one. This is a temperature power 4, area of the body. This is called your sigma. Okay, and this is a emissivity. This has no dimension. Okay, yes. So that will come in that chapter only. It's very simple. So they are asking what is this sigma? Is nothing but E by A T power 4 and what time. So they have given answer here in terms of power, watt. Energy per unit time is called what? Power. So energy by time, this is called watt per meter square, and temperature power what? 4 Kelvin. You can write temperature unit. Okay. So correct answer is what here? Charlie. Okay. Question number 11 said that our some formula is given, S is equal to A plus BT plus CT square measured in time. What's the unit of C? Very simple. You can calculate dimension of C and then you can tell unit of what C. So question number 11 I am talking, which is given S is equal to what? A plus BT plus CT square. They are asking what is the dimension of what? C. C is coming here. These all terms are added and subtracted. It means they should have what? Exactly same dimension, right? Yes. So S is, they said in meter, we know this. So S is equal to what? CT square dimensionally. So we have to find C, which is what? S by T square, L by T square, L power 1 T power 1. This is the dimension of what? Meter per second square is what? Dimension of the acceleration. So this C is nothing but what? Acceleration, meter per second square. So option A is the correct here. Okay, in question number 11. Okay, let's move on. Question number 12 is saying the wavelength of a ray of light is what? This much. Correct na? You have to convert in units only. You should know. They said something is given 0.0006 meter. They are writing this answer into what? Micrometer, microns. Microns means what? 10 power minus 6. So you have to write this into 10 power minus 6 format. So how to write? Look here. 10, 20, 30, 40, 50. If you write 6 into 10 power minus 5 meter, then we have to make here micro means 10 power minus 6 we need. So what you can do? You can write 60 into 10 power minus 6 meter. This is called what? Micrometer. So what is the answer of the question? 60 microns. Okay, you can write 60 microns or micrometer. Microns, micro, all these are what? 10 power minus 6. Yes. So correct answer is what? Beta and 12. What is the SI unit of permittivity? Okay, same thing again. When we go to 12th class, we will know permeability and permittivity, all these things comes in magnetic chapter, right? And so now to do, these formulas will come, like you know, K is what? 1, these things will come, 4 pi epsilon naught, you can find this. Then speed of light, you know, here also comes, here mu naught epsilon naught, all these things. You can calculate that, but you don't need now. So here answer is what? Delta. I am talking the important numericals only right now. Okay. So 14 question also, you know, they are asking energy density. I already discussed with you, right? Energy density dimensions are equal to what? Pressure dimension, right? So give attention here in this question, question number 14, the key is given wrong in your sheet. The correct answer is what? Charlie. Dimension of energy density, I told you 3 energy densities: electric energy density, magnetic energy density, and what? Mechanical in wire we have learned, right? So all has dimension equal to what? Pressure, because energy density is what? Energy per unit volume, which gives dimension of pressure. Means correct answer is what here? Charlie. Okay. Yes. Okay. Question number 15. Again about if you can answer if you know again these things which are coming in different chapter, like they are saying which pair is wrong. Okay, no, this they ask general knowledge, they are asking, sorry, that which is related correctly. Pressure is measured by barometer, yes we know. Temperature is measured by thermometer, yes. Earthquake by seismograph, yes. Relative density by pyrometer, no. Pyrometer is used to measure what? Temperature. Okay, we will learn in this chapter general knowledge. So correct means wrong pair they are asking, which is what? Beta, second option. Okay. Again question number 16, they are asking dimension. It should be simple for you. Physical quantity is given by some formula, x is equal to a y plus b 10 c z, where a b c are the constant. Which of the following does not have the same dimension? So let's check these dimensions. Okay, so what is given as x is equal to a y plus b 10 c into z. So here x and y are, I think, distances only, they are not mentioned, but they are looking distances only. Okay, x and y, yes, distances or displacement, right? We have to find dimension of ABC, you have to check, and they said whose are not same dimension, which are not having same dimension. Let's check it. Okay, this term and this term, look at these two terms. Then all these two terms are added, these three terms, they should have same dimension. So x dimension should be equal to what? A into what? Y dimension. So dimension of A is equal to what? X by y. Both are length. Let's call, so dimension of that is coming what? 0. M power 0, L power 0. Okay, 0 dimension of A. Then let's talk about this term. This term is a mathematical function. It should have what? 0 dimension. Correct? Yes. It means this B dimension should be also equal to what? X. So dimension of B is equal to what? Dimension of what? X. Remember it? Yes. And let's talk about this term. C into Z should have what? 0 dimension or 1. So Z should have, or C should have what? 1 by Z. So what? Should have length power 1 dimension. C is equal to what? L power minus 1 dimension, right? Okay. Let's see now options. Which of the following does not have same dimension? First option, X and B. X and B, they have same dimension? Yes, they have, because they are matching, right? Yes. Then C and G power minus 1. Yes, C and G are what? Opposite, right? To equal is to each other, right? Yes, correct. Only is also correct. Y is equal to B by A. Yes, we found it here. Where we found? We need Y is equal to B by A. This is correct or wrong? This we have to tell. So Y. Yes, because if you equate these two terms, this has value of what? 1. This A Y is should be equal to what? B. Y should be equal to what? B by A dimensionally. Okay. So this is also correct. It means what? Fourth option is wrong, which they are saying that X and A have same dimension. No G, they don't have, because let's say X and A, they have what? Different dimension. There are three terms coming, X, Y and D. So they have what? Different dimensions. So correct answer is what? Delta. Means fourth option is what? Correct. Okay. Here. Okay, move on. Question number 17. We have to derive a formula. Okay, and what formula we have to derive? Let's see. The time period of vibrations of liquid drops depend upon surface tension, radius of the drop and density. What is the formula of T? Like this, the formula is not in our books, but we can derive it. As already I told you in lecture that the formula which we are deriving may be known to us or may be unknown to us. Okay. Yes. Same procedure we have to follow. So we have to find time period. Let's write T here. Constant K. We cannot find constant, so we always put K. You know that. Okay. Okay. Three things are given. What? Surface tension S power X. Second thing given radius R power Y, and third is given what? Density rho power what? G. Here these two things you know, that also know. You may not be knowing what surface tension formula. Okay. So surface tension comes in fluid mechanics. Surface tension formula is what? S is what? Force acting per unit length, or also you can write energy by area. These are the formulas we will learn in that chapter. So surface tension you can find from here. Let's write force m power 1 L power 1 T power minus 2 by length. So answer is what? M power 1 T power minus. This is the dimension of what? Surface tension. Other things I think you know. Okay. So when you are solving these problems for this chapter alone, if you don't know I mentioned, you just check in Google and try to solve these problems. Okay. Yes. Okay. Let's put all. Dimension here is what? T power 1 constant K, m power 1 T power minus 2 power X, L power 1, radius means what? Length only, right? Density means m power 1 L power minus 3 power Z. Density, mass per unit volume, right? Yes. Okay, let's compare on both sides. Compare. What is m here? M power 0 here. Here m is what? X, and m here X plus Z. We got one. Then let's compare length power. Length is what here? No length here. Y minus 3Z. Y minus 3Z is equal to 0 again. Then time you have to compare. Time is given 1 here, minus 2x here. That's only. So x you can find from here itself. X becomes what? Minus 1 by 2. If you know x, then you can find what? Z. Z becomes plus 1 by 2. If you know both, then you can find now y also. Y is equal to 3 times of the z. 3 times of what? Z means 3 by 2. So all powers we have found. Let's put in the formula, original formula. Here you putting. Time should be equal to constant K. Surface tension power X. So S power minus 1 by 2. Radius power Y 3 by 2. And density power Z means rho. That's your answer. So if you see your options, okay. So they wrote answer like in root format. Yes, you can write in root format, no problem. Okay, so time is equal to some constant k. Look here, for them this is what negative, send it down first, and these two already have root, right? Yes, so how you write answer? You write like r cube rho by s. That should be your answer, right? Yes, so answer is what? Alpha is the correct answer for this question. Okay, yes. Planck constant already I have done just now only for you. Planck constant comes in what formula? Angular momentum formula, right? Okay, yes. Okay, so you can write mvr is equal to nh upon 2 pi. That's Planck. These all are constant. So Planck constant is simply equal to what? Angular momentum. So correct answer is what here? Charlie. What are the dimensions of permeability? Mu naught. Again you can find, I said these formulas coming, this is in different chapter. You can find from here also speed of light 1 by mu naught and epsilon. You can find here, you can find from energy density half b square upon mu naught. You don't need to worry about these things because they will come in what? Those chapters you will learn automatically. But correct answer if you want to know for permeability, it becomes Charlie answer. Okay, remember it. Okay, now we have to derive one more formula. Let's see, question number 20. A small steel ball of radius r is allowed to fall under gravity through a column of viscous liquid of coefficient of viscosity. Viscosity talking, again this come in fluid mechanics. After some time the velocity of the ball attains a constant value is called terminal velocity. Yes, the terminal velocity depends upon mass of the ball, viscosity and radius and acceleration due to gravity. Which of the following is dimensionally correct? They are asking just which formula is dimensionally correct. So here we don't need to derive anything, just we check the dimension, which dimensions are correct. But in real, if you know once you learn that chapter fluid mechanics, this is a direct formula there, we should know what is the correct formula directly. Okay, yes. Okay, still check, they are asking to check which formula is correct, and they are talking about velocity, that this velocity which is called terminal velocity, which is correct, dimensionally correct. So velocity dimension is what? L power 1 t power minus 1. You have to check in which case this is matching. Look, option number 1 is proportional to what? Mg by, they wrote something, viscosity into r. Okay, here one thing also you don't know now, dimension of what? Viscosity. So viscosity again come in that chapter only, what? Fluid mechanics. Okay, if you know it's okay, otherwise no problem. So mg I can write directly, you can write separately m also, g also, but mg is what? Force only, so I am writing m power 1 L power 1 t power minus 2. Mass means what? M power 1, acceleration is L power 1 t power minus 2, or directly is what? Force. Now viscosity dimension, actually this one, m power 1 L power minus 1 t power 1, that comes in what? That chapter. We have many formula to find viscosity. You can write viscous force like 6 pi n rv, you can use this formula. Okay, there are many formulas are there. L power 1, okay, this get cancel here, this get cancel here, so L power 1 and this goes up, becomes t power minus 1. This is a matching with what? Velocity dimension, means first option itself is the correct answer. Okay, like this you can check all 4 options, that whose dimension are matching. They are talking about that how velocity varies, means the dimension of velocity should match the other side. Okay, question number 21 already I have done for you in classroom, van der Waals equations, right? So correct answer is what? Alpha. Please see the lectures. Okay, question number 22. Okay, these are like EMS questions. Nowadays we see that EMS questions, EMS is not, exam is itself not there. So they are not asking questions like SSR and reasoning type of questions, but these are very helpful to understand the concepts. So we have given few questions to you. Let's see them. Okay, question number 22 is saying that the frequency of vibration of a wire is given by depends upon what? If some relation is given, frequency of something depends upon some constant c given, m power x given and k power what? Y given. Then they are asking that c is a dimensionless constant, find the value of x and what? Y. Correct? Na? Yes. So it's simple only. Look here, frequency depends on these two things. They are asking what is the power x and y. Yes, I told you this in while teaching theory that they can ask question like this also, that find this power, but rule will be same, you have to derive the formula only. Let's derive frequency. What is power of frequency? So dimension t power minus 1, opposite of time. Directly I am doing, don't get confused. This is what? Mass power. I think they said mass only. Yes. mass m power 1 into x, and this k is given what? Spring constant. Okay, so spring constant, if you know some formula, you can find its dimension easily. Like spring force is given k into x, energy stored in spring is given half kx square. Any formula you can use to find what? Spring constant k. So spring constant k dimension coming f by what? X. Force formula we know, m power 1 l power 1 t power minus 2 by l power 1. So m power 1 t power minus 2, this is what? Dimension of what? Your k. That we putting here m power 1 t power minus 2 power what? Y. Let's compare on both sides. Compare time dimension. Time is coming what? Minus 1 here. Time is coming here is equal to minus 2y. So from here y becomes what? Half. Done. Then compare the dimension of what? Mass. There is no mass here, 0. Mass is coming here x plus y. So x plus y is equal to 0. It means x is equal to what? Minus y or minus 1 by 2. Y we know. Okay. So these are the two powers already found. So what is our correct answer? X is coming what? Minus 1 by 2, y is coming what? Plus 1 by 2. So in option they said 2. Second option x is equal to minus 1 by 2, and third option, two options are correct here. What two options? Second option and third option. So according to the instruction, what should be the answer? No, y is what? Positive coming, right? So second and fourth options are correct. So according to them, what should be the correct answer? Charlie. In first instruction they are given. These are just for understanding only, because as I said, this pattern is not asked in NEET exam. Okay, this was M's pattern. Yes. Okay, let's move to next question. Question number 23. And this question says that if P represents the radiation pressure or pressure, C is the speed of the light, and S represents the radiation energy striking per unit area per unit second, the non-zero integers x, y, z such that these are dimensionless are. Correct na? Okay, very interesting question given here. Please give attention here. So they said some formula is given to you. Let's call anything. Let's call it what? X formula is given as P power x, S power y, and C power z. Correct. And they have mentioned what these are: pressure and speed of the light, and S means radiation energy per unit area per unit second, right? Okay. Then they said these dimensions are equal to what? 0 dimensionless. The dimension of this quantity is given what? 0, remember it. Okay. And we have to find what are these x, y, z. Okay. Let's calculate. What is the dimension of this thing given? 0, m 0, l 0, t 0. This is given in the question. Now we have to put dimension of these three things. Pressure dimension already know, they calling radiation pressure, but any pressure is what? Same dimension. Okay. Yes. So let's put it here. M power 1, L power minus 1, T power minus 2 power x. Then we dimension of S, which is called energy per unit area per unit time. Read question. S represents the radiation energy striking a unit area per second, right now? Yes. So let's calculate that, how much it comes. So energy means m power 1, L power 2, T power minus 2, area means L power 2, T power what? 1. Correct? Yes. So this comes how much? M power 1, T power what? Minus 3. This is the dimension of what? Your S. M power 1, T power minus 3, and C is the speed of the light, L power 1, T power minus 1, Y and G. Okay. Same procedure, we have to compare dimension on both sides and find what? X, Y, Z power. Let's compare dimension of mass. M power 1 into X, M power 1 into Y. So X plus Y is equal to 0, it means X is equal to minus Y. Let's compare dimension of what? Time or length. Length is here. L power minus 1 into X, 1 into Z. So minus X plus Z is equal to again 0, X is equal to what? Z. Time dimension, minus 2x minus 3y minus z is equal to 0. X and y relations we have calculated. So in this equation, let's replace them. Let's replace y and z in terms of x. Then we getting is minus 3x minus 2x minus 2y. So x comes what? 1. If x is 1, then we see y is here. Y will become minus 1. If y is minus 1, then z also what? 1. So these are coming after solving this equation. So we see these are given in what? X is equal to plus 1, y is equal to minus 1, and z is equal to what? Plus 1. Means option 1, option 2, option 3 all are correct. Means the first code is correct. Means 1, 2, 3 all are correct. Okay. Let's do one more last question. 24. So they are saying that which of the following pairs have same dimensions. So again this depends on that how many things you know. So angular momentum and work, let's calculate. They are asking which has the same dimension. Angular momentum, I just told you mvr. So mvr, let's check. We know m power 1, l power 1, t power minus 1, l power 1. So this become m power 1 and l power 2, t power. This is angular momentum dimension. Energy dimension is simple, which we know. Work or energy. Work is what? Force into displacement, or energy, same thing. M power 1, L power 1, T power minus 2 into L power 1. So it become M power 1, L power 2, T power. So these are what? Not matching. They are asking which pair has the same dimension. So first pair, angular momentum, work doesn't have same dimension. Torque and work. Okay, work already you found here. Torque formula will see R into F, distance into force. So yes. So give attention here. This will match because torque is what? R into F, perpendicular distance into force. So force m power 1, L power 1, T minus 2, and length is what? L power 1. So this will matching m power 1, L power 2, T power 1. This is a torque dimension, and work is already be calculated here. These two are what? Equal. So these two pair has what? Same dimension. If you see next, they will not have same dimension because energy dimension different, and Young's modulus. In lecture I told you all modulus has the dimension of what? Pressure or energy density, not energy. So this will not match. Light year and wavelength. Wavelength is length only, so dimension is what? L power 1. Light year is a unit of what? Again length. The distance traveled by light in 1 year. So it's a distance only. So here we see how many options are matching. Option number 2 and option number 4, they are correct. 2 and 4 are correct. Means in code the correct answer will be what? Charlie. Option second and option 4, they are what? Correct answer. Okay. So this is sheet, first sheet about units and what? Dimensions. Okay. Yes. Last 3-4 questions are there we know doing because they are paragraph type of questions which are not asked in what? NEET exam at all. So in next sheet, next paper will give just what? Purely NEET questions alone. Okay. Yes. So hope you understood all these things, and we will discuss the second sheet, means based on what? Error shown. Okay. Thank you.